Hi everyone, Mrs. Broderick here, and I'm going to walk you through the Note 7.3 Day 1. So we're going to summarize what we've learned about angles and arcs and how we can use arcs to find angles. So the most important thing is to pay attention to the location of the vertex. That is always the most important thing. First thing you want to look at. So number one, looking at our angle x. Well, x is at the center of the circle. So our vertex is at the center. Classification, well, we call these central angles. And in order to find the measure of our central angles, we know that the central angle is equal to the measure of the arc. So if I look at where my angle opens up, it intercepts arc AB, so that's going to be equal to the measure of arc AB. Okay, so the measure of the angle is always equal to the measure of the arc. Number two, the vertex is on the circle. Okay, we learned in 7.2 that these are called inscribed angles. And with inscribed angles, look for that intercepted arc, which again is going to be AB. Our intercepted arcs, though, we're going to use the intercepted arc by taking half of it. So we're going to do half the measure of arc AB. So in this case, the measure of the angle is equal to half the measure of the arc. 3. Vertex is also on the circle. Okay, these are called chord tangent angles because they're formed by a chord and a tangent line. Again, since the vertex is on the circle, it has the same property. This one's just a little more tricky. Some students have trouble with picking out the intercepted arc, but again, it's what arc of the circle does the angle cut off from the rest of the circle. So in this case, it's still arc AB. So again, the measure of the angle is always equal to half the measure of the arc. Okay, 4, now we get into angles that are outside of the circle. So the vertex is actually on the exterior. So it's outside the circle. Okay, and if we look at the type of lines that make up this angle, since they're cutting through the circle and extending outside, this is considered a secant angle. And anytime we have this type of a situation going on, we do half the measure of the large arc minus the measure of the small arc. So if I look and I follow this angle as it cuts through, it's actually cutting off arc AB, and it's also cutting off arc CD. So we use both of those arcs. So we're going to do the measure of arc AB minus the measure of arc CD. So the way I like to remember this one is the measure of the angle is equal to half the big arc minus the little arc. So we're going to subtract. Okay, number 5. Again, vertex is outside the circle. Okay, this one's formed by a secant and a tangent. Okay, if I look, this angle is going to cut off arc ABC as well as arc AD. So we're going to subtract again. So we're going to do 1/2 the measure of arc. Now this one looks like it's going to be a major arc, so let's call it arc ABC. minus the measure of arc AD. So again, let's not do it that way. Let's write it in a general form. So the measure of the angle is equal to 1/2 big arc minus little arc. Okay, number 6. Again, vertex is outside. If we look at the two lines that make it up, those are tangents. So this is a tangent, tangent. Okay, so again, we have two arcs. So the large arc would be arc ABC, and our little arc would be arc AC. So here, and actually let me scroll up just a little bit, give me a little bit more room. So we're going to do 1/2 the measure of arc ABC minus the measure of arc AC. Now, there's a shortcut for this one that I like to use, and sometimes we call it the ice cream cone. So if you kind of look at this sideways, it looks like we got an ice cream cone, right? So the circle is the ice cream, and then the two tangent lines would make the cone. So the other way we could find the measure of our angle is we can do the measure of the angle plus the measure of the arc will equal 180. Okay, so really you can do these problems either way. I like the shortcut of doing the measure of the angle plus the measure of the arc equals 180. Okay, 7. Now we have an angle that is inside the circle, but it's not at the center. So inside the circle, big thing is that it's not at the center, because then it would be a central angle. Center. Okay, so if I look at that, and what happens with these is we have vertical angles, right? We know vertical angles. We know vertical angles are congruent. But if I look at the arcs that those two angles open up to, right, we get AB and CD. Clearly, AB and CD are not congruent, right? So the angles are congruent, but the arcs are not congruent. So what we do when we're finding these, and these are called chord, before I forget. So in order to find this angle, we actually take the average of the two arcs. So the average of the arcs that the angle and its vertical angle open up to. So we're going to do 1/2 of arc AB plus arc CD. So the measure of the angle is equal to 1/2 arc plus arc. So if it's at the center, it's equal. On, it's half. Outside, it's half the difference of the two arcs. If it's inside, it's half the sum of the two arcs. So that's the main thing you need to know. Don't focus so much on knowing it's a tangent, tangent, or a secant, tangent, chord, chord. That's not as important as locating the vertex. So let's do some examples with these. So for each question, write out the appropriate formula, plug in the known values, then solve. So number 1, first thing, vertex is on the circle. So whenever it's on the circle, the measure of the angle is equal to half the measure of its intercepted arc. So half of 70. So x is going to be 35. Okay, number 2, vertex is on the circle. This time we have the angle and we want to find the arc. So it's still the same formula. The angle equals half the arc. This time the angle, which we know is 50, equals half the arc, which is x. So to solve this, we multiply both sides by 2. So we know that that arc would have to be 100 degrees. Number 3, our vertex is outside of the circle. Okay, so when it's outside, I notice it cuts off the 70-degree arc and it cuts off this 90-degree arc. So when it's outside, the angle is equal to 1/2 big arc minus little arc. So 90 minus 70. So 90 minus 70 is going to be 20. Well, 1/2 of 20 would be 10. Number 4, this time we're finding an arc, right? This is our big arc. Here's our little arc, and we know the measure of the angle. So notice I'm using the same formulas, I'm just plugging in my variable in different spots. So the angle is equal to 1/2 the difference. So big arc, the big arc is x minus our little arc, which is 25. Okay, so to solve this, let's take care of this fraction first. Let's multiply both sides by 2 to get rid of the 1/2. So 80 equals x minus 25. Add the 25. So we know that that arc has to be 105 degrees in order to get an angle measure of 40. Okay, number 5. All right, so angle is on the exterior of the circle. So it cuts off this close arc here, and it also cuts off this 260-degree arc here. So the angle, 80, is equal to 1/2 the difference of the two arcs. So big arc, 260, minus little arc, which is the x that we're trying to find. So multiply both sides by 2, so we get 160 equals 260 minus x. Subtract 260, so negative 100 equals negative x. So x is going to equal 100. Now, we could use ice cream cone, right? That ice cream cone shortcut that I told you guys about. So it's the closest arc plus the angle equals 180. So x would equal 100. So either way you want to approach those, we'll get the same answer. Okay, number 6. So vertex is outside of the circle. So I've got my close arc here, my big arc here. Well, I don't know the measure of the pink arc, and I don't have the measure of the angle. But if we notice, we have a diameter. So if we have a diameter, that means we have a semicircle. So the pink arc and the blue arc must add to be 180. Well, if this one's 110, that makes the pink arc equal to 70. So sometimes you'll have to do a little bit of work before you can do your equation. So the angle is equal to 1/2 the difference of the two arcs. So big arc minus the little arc. So we're going to get 1/2 of 40. So that means that that angle must be 20 degrees. Okay, 7. Now our angle is inside of the circle. So I pay attention to the angle and its vertical angle. And then the arcs that the angle and the vertical angle open up to. So with a chord, the angle is equal to 1/2 the sum of the two angles. So 1/2 of 100 plus 180, or sorry, 100 plus 80 is 1/2 of 180. So that angle must be 90. Number 8, again, I've got the 105, it's vertical angle, and pay attention to where they open up. So the vertical angle opens up to the x, the angle of 105 opens up to 100. So the angle is equal to 1/2 the sum of the two arcs. So since our x is in the parentheses, let's multiply both sides by 2. So 105 times 2 would be 210 times x plus 100. Subtract the 100. So we get 110 for that arc. Okay, so now on to page 23. So now we're going to talk about an arc length. So we've been talking about the measure of the arc, but what if we wanted to actually measure the distance between the 2 points of an arc of a circle. So the length of an arc is equal to the circumference times the fractional part of the circle determined by the arc, right? Because the arc is going to take up a piece of the circle, so it's taking up a piece of the circumference. So by taking the measure of the arc over 360, that finds us the fractional part, right? This part here. And then if you notice pi times d, well, that's circumference. So we're taking a fractional part of the circumference. Man, I apologize for my handwriting right there. Okay, example 1. Find the length of a 40-degree arc of a circle of 18 centimeters radius. So the length of our arc is going to equal 40 over 360, and that gives us the fractional part. Well, if our radius is 18, our diameter is going to be double that, right? So that's going to be 36. So 40 over 360 times 36 pi. Okay, so if we multiply that out, we end up, and leave it in terms of pi, we end up getting 4 pi. So that would be 4 pi centimeters long. Okay, 2, find the radius of a circle whose circumference is 32 degrees. So we know we know the circumference on this one. We want to know what the radius is. Well, circumference is equal to d times pi. So the circumference is 32 pi. And if I can solve for the diameter, then I can find the radius. So divide both sides by pi. Okay, pi's would reduce. So we're left with 32 is equal to the diameter. Well, if our diameter is 32, our radius is going to be half of that. So we know the radius must be 16. Okay, and then example 3, back to our length of, length of an arc formula. So we're going to use a circle of a 12 centimeter radius for both of these. So if we've got a 30-degree arc, so 30 over 360, well, if our radius is 12, that means our diameter is 24. So 30 over 360 times 24 pi is going to leave us with just 2 pi centimeters. Okay, 105 over 360 times our 24 pi for B. So multiply that out and we get 7 pi centimeters. Okay, next definition is the sector of a circle. So a sector of a circle is kind of like a slice of pizza. Okay, so it's the area bounded by 2 radii and the arc of a circle. So looking at this diagram here, you can see OA and OB are radii of the circle. We've got arc AB. So if we think of this whole section here, that's our sector. So to find this area of a sector is very similar to the length of an arc, right? So we want a fractional piece of now the area. So we take the measure of the arc over 360 times r squared pi. So we multiply times the area. So if we want to find the area of the sector on example 5a, well, our arc is 26. Our radius is 14. Okay, we multiply that out. Unfortunately, this is not a very nice one, but if you use the fraction key in your calculator, you're going to see 637 over 45. pi, and then it is an area, so we're going to use centimeters squared. Now, leave your answers exact unless it tells you to round. Okay, because if we're not told how to round, well, then we could all round differently. So leave it exact if you're not told how to round. So just leave it as an improper fraction. Okay, B, now our angle is 90. And remember, the central angle is equal to the measure of the arc. So we're going to do 90 over 360 times 10 squared pi. So do that, and we get 25 pi. Units are feet, so feet squared. Okay, last page here, just a little bit more work with our area of the sector and area or length of an arc formulas. So it says find the distance in terms, well, let's read the first part first. Whew, I'm getting ahead of myself. So circle S is cut by 3 diameters that create equal angles at the center of the circle. Find the distance in terms of pi to walk along UT, right? Well, if we want to find the length of arc UT, we need to know the measure of the central angle. Well, we know it's divided up evenly. We've got 6 different sections here. So if we do 360 divided by 6, that tells us that each of these angles must be 60 degrees, right? Put it all in here if I wanted to. We really only need angle UST, but the angle of the measure, the measure of the angle is equal to the measure of the arc. So that's going to be 60. So to find our arc length, we're going to do 60 over 360. We want our diameter. So the radius is 10 from the diagram. So I know my diameter is 20. So multiply that times circumference, which would be 20 pi. So we multiply that out and simplify it, and we end up with another fraction. We're going to end up with 20 over 6, which is going to reduce to be 10 over 3 pi. We're not given any units, so I'm just going to put U for units. Now, if we want the area of one of the sectors, so remember we want this whole area here. Well, now we do 60 over 360 times the area of the circle. So now we're going to use the radius. So times 10 squared pi. So multiply that out. We get 50 over 3 pi units squared. And finally 11. So circle R is cut by 2 diameters that are perpendicular to each other. So we know if they're perpendicular, we get a right angle. So we want the distance from Q to N. So again, I know I have a right angle for my central angle. I know my radius is 6. Well, if my angle is 90, my arc is going to be 90. So we're going to do 90 over 360 times that circumference. So our radius is 6, which makes our diameter 12. So multiply that times 12 pi. And we get 3 pi units. And last but not least, now we want the area of one of those sectors. So 90 over 360 times our radius squared times pi. So work that out and you get 9 pi units squared.